We'll be getting started soon. This is just a quick sound test. Hello everybody and welcome to the stream. How are you doing? Now this stream's going out on a Monday. Usually it's on a Tuesday, hashtag Chess Tuesday. It's on a Monday today because I'm going away. I'm actually going away to write an Excel course, which is going to be hopefully fire content, really good stuff. And that's why I'm streaming today. So I think this is going to be a quiet one. I haven't been able to publicize this one much, and I don't think we've got anybody in the chat at the moment. No, Andrew is in the chat. Hi Andrew, how are you? Andrew, I think you're in Australia, so this is probably suits you well, this streaming time. So anyway, Andrew, let me know in the chat how you are. So we're into the chess challenge again, and the chess challenge is our infinity project. We're trying to create a chess computer in Excel, and we've had some weeks where we made big progress, some weeks where it's kind of plateaued and we've struggled a bit. I've struggled a bit, but that's what it's like, computer programming. That's what it's like, Excel development. Progress is not linear. You have good days, less productive days. We've got to learn how to handle all of that. Anyway, this is what we've got to now. So I can click on pieces on the board, and the bishop is working, the knight is working, the rook is working. The pawns are not working yet. And this approach is a new approach we've implemented, I think, about in Chess Spreadsheet Skunkworks number 19. We went through a new approach because we were having problems with the blocking pieces. How do we program a blocking piece in chess to make sure that Excel doesn't look beyond that blocking piece? And that entailed an entirely new approach that we conceptualized, tested in a controlled environment on a small scale. Now we're implementing in our main file. So yeah, I think progress has been slow, but maybe we're picking up some progress now. Andrew says, yes, it's 8:15 in Australia. Brilliant stuff, Andrew. So yeah, let me know, Andrew. And I know we've had some conversations of emails about a file you've sent me, and I think that's going to be a good one to do a stream on. I won't be able to do it this week, the stream, but I think next week I will certainly look at doing a stream on the file you sent me, because it's a good example of how we can get stuff done faster using VBA and some other techniques. So this week we're going to look at the pawn, programming the pawn move, because all of the other pieces are done. I did do a little bit of preparation this week. I noticed in the VBA editor, I was looking down at the bottom. So where are we? Yeah, these two lines of code here. And these are called, well, I've put some annotations here. I've called them movement range limiters. But I've actually realized we don't need these lines of code, because we don't need these movement limiters. Go back to the previous stream if that doesn't make sense to you, and it often doesn't make sense to me when I come back to it, so it might require a little bit of revision, but we're on fairly high level stuff here. We don't need these move limiters because we can go down into the table, and these knights moves are working off rows 55 to 58 in this table, and you can see we've limited the moves. We've limited the moves in this table, have we? How's this table working? Yeah, we limited the moves using this end column here in this table. So I went ahead in the code and I wanted to see if these lines of code were actually doing anything. And the way to test that, very simple, commented these lines of code out. So just putting an inverted comma there, that's going to make these lines of code into a comment. It's going to make them green in the VBA editor. That means that Excel is going to ignore them when it runs the code. But you might say to me, well, Chris, why don't you just delete this code? You know, that's a fair question. Well, because I might use this code later and I've got an idea of the trajectory, the plan for this particular stream. I think this code is going to come in useful later. So rather than delete it, sometimes it pays dividends just to hold on to it for a bit. I'm going to do that by commenting it out. Now I'm going to run the code. And I know this code is to do with nights. So I'm going to click on all the nights. And are we getting the expected results? Yes, we are. Going to right click on this night, drag handle to the middle of the board, and then clicking again, and we can see, yeah, we're getting the expected results there. So that shows, yeah, we don't need that line of code. And that's something that is good practice and something I certainly do a lot. When I come back to a piece of work, having been away from it, I often see opportunities for improving efficiency. And that's what me and Andrew's in the chat, that's what me and Andrew have been talking about, improving efficiency of code. And I go back to some files I've done on YouTube and I'm thinking, oh, that's not that efficient. So it's normal when you open up a file with a fresh pair of eyes to make some efficiency improvements. So how are we going to program these pawn moves? Well, let's go back to the engine, go back to our concept. We've got our different move types, which are represented in these columns up here. And then this table, we can turn the move types on and off for each piece. So we can go up, down, left, right. And the queen, for example, does all of those. Goes up, down, left, right, and the diagonal moves as well. So this is how we can turn these movement types on and off. So are any of these movement types going to work for the pawn? Well, the pawn is moving up, a white pawn, the way we've got the board set up anyway. The white pawn is moving up and the black pawn is moving down. So already I can see some complexity coming in here, because if it's a black pawn, it's going to move down. If it's a white pawn, it's going to move up. So we're going to have to think about how to program that. And perhaps we can do it. We can just go ahead here and for the white pawns, turn on the up moves. So I just put a Y in there, then Control D, take those Ys down. And then for the black pawns, turn on the down moves here. So I can just select this cell, Control D is going to auto fill down, you can see in your screenshot. So what's that going to do? Control S, save the file. So we've changed something, let's go and test it. And this is how it works really. Change something, test it, change something, test it. Let's see if we can move towards some improvement. So I'm going to hit the pawn now. And we can see, yeah, we've got all of those up moves there. That's what we expect. You can see there's no limiter. There's no limiter on these moves. And remember, we had that comment. We had that code that we commented out just now. That was to do with limiting. So there's a conceptual link there, which is why that code might come in useful. So this is what we expected. Yes, this is not how a pawn moves, but it's an intermediary step. It's a small step in the right direction, keeps the stress levels down. That's what I'm talking about. And it's working for the pawns here as well, the black pawns. So let's think about limiting these moves. And let's say first, let's limit the pawn to a single move. Remember, a pawn that's on its starting square can move 2 squares. A pawn that's not on its starting square can move 1 square forward, but can also capture diagonally. And what we've found in this series is that the pawn moves are some of the most difficult moves to program, even though, you know, a pawn you don't think is a particularly powerful piece in chess. It's not a particularly powerful piece, but the moves are difficult to program. So what are we thinking here? Right. Okay. So I'm looking at this. Yeah, it's going to be to do with rows, isn't it? Because the pawns are going up and down. So this line of code, I wonder if we can just resurrect it. So I've removed the inverted comma. So the code is now active, if you like. The VBA editor will exit this line of code. I've changed the text to a P for pawn. Then let's say the absolute value of row count is Okay. Yep. Equals 2, let's say. Well, let's say it's more than 2, which is going to catch any other kind of eventualities. Let's try equals 2 first. Okay, so this should have the effect of limiting those possible moves. So Control S, save the file. Going to go to the pawn now. Okay, we don't have any limiter on there. Okay, so what's happened there? Row count equals row end. If I change this to more than okay, so we're going to, so we're looking at the engine here. We're going to, yep, so the up moves and the down moves, how are they configured? Up row minus 7, okay, seems to make sense. Okay. Seem to have missed the text there. Let's try it again for the pawn. Okay, we've got that limiter on there. Looks good. Is it working for the black pawn as well? Yep, that seems to be working nicely. That gives us 2 squares. What if we wanted 1 square? Should be fairly straightforward to change this 2 to a 1. Control S, save the file. Okay, we've got our single moves there. So can we program this starter move? So now hopefully wherever I move the pawn, it's just going to give me 1 candidate move, 1 square ahead. What we're looking to do is, if the pawn's on the starter square, of course in chess, if the pawn is on its starter square, then it wants to be able to move 2 squares. So in the VBA editor, I'm thinking, where are we holding this information about the current square? The current square. Okay, current square. We've got this variable here, current square. This current square variable, how's it working? Let's go and find it. Yep, so it's working from this top left cell.address application.caller. Application.caller is the object that triggered the macro, in other words, the shape, the piece. So it's saying the cell address of that shape, which is really clever. Like, this is something that always impresses me in Excel. Excel can look at an object, a shape or a button, and understand where that shape is positioned in relation to the cells in the spreadsheet. So it can tell, for example, that this pawn shape is on J4. So we've taken that information, exploited that capability, stored it somewhere, stored it in this variable, because, yeah, it's going to be useful for us later. So we can say, let's copy paste. Yeah, range current square. Okay. And let's see if we can, some restructuring here. Okay, so if current square range current square dot row does not equal 2. Okay, can you see the problem here? There's kind of different rules here for, and it's going to be 9 anyway. Different rules here for the, okay. Different rules for the black and white pieces here. Okay. So have we got a way to identify the color of the piece? Are we doing that anywhere? Looking through these variables here. Got the name of the piece. Okay. Now we can use the piece name here to do this. Need to identify if it's a black or white piece. We can use the piece name here. Yep. Because the first letter of the piece name is always W or B. Right, as always, more complex than I thought. Right then. Okay. Okay, so if we're on the 9th row and let's see how this piece name variable is working. Okay. From the 9th row, if we are on the 9th row, let's do it this way. And piece name, the first letter in the piece name variable, so left piece name 1 equals W, so it's a white pawn, and it's in the 9th row of the spreadsheet, which is the first rank, the second rank rather, on our chessboard. Then so we've got a white pawn. Okay, and then I think we need this. We'll build this up step by step. Okay, I think I've got a better way to do this. Okay, let's use an or here. So let's say if we're on the 2nd or 7th rank of the board, am I making a pig's ear of this? What do you think, Andrew, if you're still watching? Okay. Okay, I think I'm going to have some connected if statements here. Let's try this then. And or, okay. Now the same rule for the black piece. Okay, let's comment this out for now. I just want to know if the code is getting in here. For B for black. Yeah, Andrew says your 7 should be a 4. 4 and 9. Okay, I think we're on track here. Okay, it says message box, pawn on start square. And then let's just exit the routine there. Okay, right, so if I hit pawn now, pawn on start square, yep. And for the black pawns, yes. Okay, and then, so if the pawn is here, for example, do we get in there? No. So I didn't see the message box, which shows we're not going into that part of the conditional statements. Okay, fine. Shall we see if the setup board routine is working? Yes, it is. Okay. That seems to be okay. Okay, is 2. Say movement range. Limiter. Yep, Andrew, I think this is what you're suggesting for the code. I think that's accurate. Else, okay. So if the pawn is not on the start square, let's just annotate this quickly. If pawn on start square, then else is if pawn not start square. Okay, then we want to get out of the loop, but the exit condition is going to be slightly different, because if we get here, the pawn's not on the start square. We know that from our helpful comment. Pawn's not on the start square, so it can only move 1 square forward. So we set the conditions to exit this loop. Okay, sense checking that. Looks reasonable. That's accurate. Accurate. It's accurate. Let's move the pawns then. Okay, accurate. 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 Last one. Okay, and then let's put the pawn in front of the king, in front of the queen rather. And are we accurate there? Yes, we're accurate. Good. Control S, save the file, set up the board. Seems to be reasonable. Okay, seems to have worked well there. Right, so what else can we do here? What I'm thinking is, of course, the pawn actually goes up and to the left to capture, up and to the right to capture. The pawn can capture diagonally. So can we, yeah, can we capture that? We should be able to. Okay. Looking through the code, seeing where, if we've got the infrastructure, if you like, to program in some of these pawn capture moves. So we have previously limited the knight moves there. Different ways to do this. We could, of course, just have another move type and call it here and call, let's go to the other side of the screen. Have another move type down here and call it pawn capture. And that means we're going to have more detail on this sheet in the file and less code. The other approach would be to try to code this move limiter somehow in here. And that would mean more code in the VBA editor, less stuff in the Excel file. Which of those two is preferable? Well, that's a design decision for you to make. My preference is usually to have more in the spreadsheet, more in the Excel file, and less in the VBA editor, because the VBA editor is almost always more difficult to understand. Code is always more difficult to understand, usually anyway, than what's going on in the spreadsheet file. So that's a design decision for us to make. Yeah, Andrew says it might be easier to use the sheet. Well, I'm taking that as a vote of confidence, Andrew. And we're going to program in these pawn moves. Okay. Pawn up left. Pawn down right. Pawn down left and pawn down right. Okay, and that means, well, up and left is going to be, it's going to be -1. And -1 columns. The start and the end are going to be the same. The start and oh yeah, thank you, Andrew. Pawn down right, pawn. This should be pawn up right. Okay. Pawn up and to the right, so that's going to be -1 row and 1 column. And pawn down to the left. It's going to be 1 row down. To the left, it's going to be -1. Pawn to the right is 1 row down, and to the right is going to be 1 column. Okay, and then these won't actually matter. Maybe they will. I don't think these will matter. Yep, just going to put 1 in all of these. Let's say PCP, pawn capture. Okay, Control S, save the file. So now I want these in up here, Control Alt V E and V again, so E to transpose, V for values. Okay, didn't work. Okay, so I'm going to update the table with these pawn moves. Yes. So these are all yeses. Just fill out the nose here. Going for the black pawns. Filling out the black pawns here. So yeses for the black pawns. So the black pawns are going to capture downwards, of course. And there we go, looks reasonable. Okay, looks reasonable. Control S, save the file. Okay, right, what's going to happen now? Well, we're expecting to see those diagonal moves for the pawns. So I've saved the file, haven't got the diagonal moves there. Not sure if we can configure this in this way. I know. Got to update the code. Got to update the code to accommodate the new rows and columns, new rows in the table there. So we're now up to 16. Here we go. Okay, good. Yeah, that's what we're looking for. That's what we're looking for. That's what we're looking for, and that's what we're looking for. Okay. Interesting. Okay. Tempted to leave it there this week, but you can see we've made a bit of progress with the pawn move. So what we need to say now is that this move is only possible, the diagonal move is only possible if there's a piece there. I've got an idea of how we can do this because we know where all the pieces are. We know where all the pieces are from because their positions are populated here. So we're going to say to VBA, that diagonal cell, the address of that diagonal cell, does it appear in this range of values here? If it does, then that's a possible move. So that's the logic we're going to have to program next. Then the pawn moves will be done. Yep, the pawn moves will be done. If the pawn moves are done, then we can start thinking about those blocking ideas. Let me know any final questions in the chat. Who's with us? Only a couple of people with us this morning. Well, that's Monday morning. That's Monday morning live streaming, hey? Let me know if there's any final questions, but that's the plan. So configuring these capture moves properly, then we'll look at putting in the intervening pieces, the blocking pieces, and then maybe once we do that, we'll have a bit of a review. If we're in a position where we can put a piece anywhere on the board, and the piece is accurate in terms of the possible squares and possible captures, and accurate in terms of the blocking pieces as well. If we can get to that situation, then we should, have a pause there and, reflect and possibly look at some new approaches, or maybe push things forward. So that's what we'll be trying to do in the next 2 or 3 streams. But just speaking out loud, I've thought of 2 or 3 coding challenges that we're going to have to meet there. Andrew says you could say if piece name equals W or B. Yes. Yeah, absolutely, Andrew. I think you're talking about the capturing the pieces. Yep. Yeah, you can see I've already used some code today, which is, where is it? Down at the bottom here. Yep, so I've said if left piece name equals 1 is W. So that's just taking the first letter of the piece name, which is here. So if the first letter, that left function just means if the first letter is W, then we're going to do something. So yeah, we've got a mechanism for distinguishing between the colors in the VBA. Okay, guys, so bit of progress there, and hopefully a bit of direction for us to go in the next few weeks. So next week should be back on Tuesday. So it should be Tuesday, 1800 UK time. And I'd love to see you there. Okay, take care, guys. See you soon.